A completely empty, flat desert covered in sun, or the single largest gold deposit ever discovered on Earth? Why not both? Here's the mighty Geologists Desert in Uzbekistan, where this golden hole is still growing. Mountains are being created live, and it's triggering a hidden conflict. For centuries, traders on the Silk Road walked right over this ground, having no idea that beneath their feet lay an enormous fortune. You can't actually see it. Not even a single sign of shiny gold nuggets would bring your attention. It was like this until 1958, when Soviet geologists cracked the code. They were tracking a poison after a massive anomaly of arsenic was detected. This strong chemical substance often travels with gold. That's how they discovered Maruntau, which has now become the largest open-pit mine in the world. The hole is nearly 4 kilometers wide and over half a kilometer deep. It can easily be seen from space.
Hey, hit subscribe.
Now the scary part. It's getting deeper every single day. Even today, the open pit still gives people around 2 million ounces of gold a year. That's over 60 tons of pure metal. Picture a solid gold structure weighing as much as a commercial airliner. Why dig so aggressively? It's where geopolitics step in. The nearly endless gold supply acts as Uzbekistan's ultimate economic shield. This is actually a brutal choice between financial and political independence and an environmental disaster. The price is extremely high. We mentioned before that Geologists Desert is naturally flat as a pancake. But what about those weird mountains surrounding the pit? They shouldn't be there. Zoom out on the map for a second. Those are actually man-made mountains of waste rock. Material dug up just to get to the gold. They are so massive that they are creating their own wind patterns, which now sweep toxic arsenic-laced dust across the area. Air quality is dramatic even miles away from Maruntau. Also, digging deeper requires quickly pumping out precious groundwater. It leads to severe water contamination in an already fragile dry region. It appears that people are not only changing the topography of the country, but also playing risky games balancing profit and ruining nature.
Do you know how much gold has been mined by humans throughout history? About 216,000 tons, and 2/3 of this amount was mined after the 1950s. Different countries, different times, thousands of different people involved. But what if you found huge deposits of gold in one place? What if a giant gold ore deposit was discovered? No, not just giant, but super giant. This is exactly what was found in China. A group of geologists discovered about 40 gold veins with about 330 tons of gold ore. But that's not all. 3D modeling has shown that even more gold lies underneath. At a depth of about 9,800 feet, there may be several hundred more tons. In short, there is a chance that they will discover deposits with about 1,100 tons of gold. Can you imagine how much that is? If not, that's about $83 billion. Wow! Experts say that this deposit contains approximately 4.9 ounces per ton of ore. It seems that this is negligible, but in fact, it's a high indicator in gold mining. Usually, 0.35 ounces per ton is awesome. If all calculations turn out to be correct, it will be the largest gold mine in the world, even bigger than the South Deep mine located in South Africa, with its 1,025 tons of gold. Everyone is worried. Everyone is happy. Gold, gold, gold on their minds. Everyone wants gold. Everyone buys gold. Gold is rising in price. Gold is more reliable than Bitcoin and cash. Gold is associated with wealth and luxury. Gold is always a valuable and profitable investment. But hold up, why is it so? Why do people go crazy over some shiny metal? The fact is that gold has both practical and psychological value. For centuries, gold has represented power, prestige, and wealth in different cultures. It seems we're born in a genetic memory that gold is valuable. Think of how many problems gold has brought to literary heroes and how many gold-related adventures we've seen in movies. Gold makes people happy and greedy, cruel and intimidated. That's why so many people love it. Yes, it glitters, it's beautiful, but it's also practical. Gold doesn't rust, it doesn't corrode, it can be stored for a long time, and it doesn't deteriorate. It's literally a reliable investment. All other savings may lose value because of crises, but gold remains unchanged. The only problem, it can get stolen. In addition to jewelry making, gold is used in electronics, medicine, aerospace, and many other industries. Bitcoin has a value because of the public support of people around the world. Money has value thanks to the support of authorities. Gold has value on its own. It's tangible and visually appealing, and its worth is also supported by people's centuries-old belief in its enduring value. But never let gold cloud your mind. Many people lose their honor and even their minds over it. Avoid this trap. It's just a shiny piece of metal. There are other precious metals in the periodic table: palladium, silver, copper, platinum. Why is gold number 1? Cheaper metals such as copper, iron, lead, and aluminum corrode and rust. Aluminum is also not durable. Platinum and palladium are more expensive than gold, but they're too rare and difficult to mine. You won't make many coins out of them. Silver is softer than gold. It tarnishes, scratches, and deforms. And, well, to be honest, gold is more beautiful. But there is another reason why gold is so expensive. It's quite difficult to get. Gold mining is a very laborious and long process. In movies or documentaries, you might have seen people standing at the mouth of a river, collecting silt and clay, sifting it through gauze and small nets, and finding gold particles there. That's one of the methods for how gold is mined. You have to work hard to get just a few small pieces. How do they find gold? It used to be luck. Someone was walking along the shore and saw something glistening in the water. But today, gold detection methods are much more effective. Geologists know that gold is present in almost all rocks and soil, but its particles are so tiny that they're not visible. But when the concentration of gold is high and noticeable, work begins to extract it. Special geological teams are engaged in searching for these sites. When they discover gold, they drill wells, then take soil samples and decide if there's enough metal to carry out large-scale mining. Production depends on the deposit. If gold is in hard rock, miners drill holes, place dynamite, and detonate it. The explosion breaks the rock into pieces so they can extract the gold. But this is just the beginning of the work. After collecting large pieces of rock, workers take them to factories to extract valuable material. At the first stage, specialists break large pieces of rock into smaller ones. Using crushing machines, they grind the ore into tiny pieces, similar to gravel. This gravel then enters rotating drums filled with steel balls. The drums spin, and the balls grind the gravel into powder under pressure. This mass is then mixed with water and passes through special filters. After that, gold is extracted from the ore using chemical solvents and complex purification systems. It adheres to carbon, then is separated from it, followed by several additional processes, including electrolysis and further purification. At the end, the gold is melted and separated from impurities, then poured into ingots and sent to other plants for further processing. Yes, it's a difficult and time-consuming process, and quite a long one. And it's not always profitable. You can find a deposit of precious metal, but it will be too expensive to extract it, and the amount of gold there won't be enough to make the effort worthwhile. Only 10% of the world's gold deposits contain enough precious material to pay back for its extraction and processing. There are many areas filled with gold. Do you know how many of them are suitable for productive mining? Less than 0.1%. So this is probably another reason why gold is so valuable. But is there any other material that causes a lot of excitement? Oh yes, this material is called liquid gold, and this is helium. That's the gas used to inflate balloons, but this is not its main value. Helium is capable of reaching ultra-low temperatures, is superconducting, and is lightweight. Helium is used in medicine for diagnostics. For example, for magnetic resonance imaging. Helium cools nuclear reactors and maintains rocket fuel temperatures during launch. Divers breathe a mixture of helium and oxygen during deep dives to avoid diseases associated with pressure changes. Helium is crucial for the modern world. Another precious material is graphene. It's not just one of the most durable materials in the world, it's a highly conductive material. Heat and electricity pass through graphene easily, which makes it very promising for the development of what? Considering that graphene is also flexible, water repellent, non-toxic, and has antibacterial properties, it's suitable for developing everything. Medical equipment, mechanical engineering, electronics, construction, logistics, energy conservation, space and underwater industries, and much more. Scientists believe that graphene has the potential to enable revolutionary new technologies that could change the lives of all people. Something similar happened with silicon, which is actively used to create semiconductors and rechargeable batteries. It's possible that without silicon, we wouldn't have smartphones, laptops, and other electronic devices. Graphene may also lead to a new technological leap. When the world switches to renewable sources of energy and uses electric transport, graphene can become technological gold. During tests, graphene batteries have shown that they charge more than 70 times faster than regular ones and last 3 times longer. At the same time, they're cheaper and environmentally friendly. Okay, that sounds cool, but where do we get this graphene? It's obtained from graphite, which lies in the bowels of the Earth. One of the largest graphite deposits is located in South Australia. 200 million tons of high-quality graphite. It sounds like it could be enough for the entire planet.
In ancient Egypt, in an ancient temple, in a dark ancient hall, ancient people are performing a very ancient ritual. In black robes and hoods, by the light of burning candles, they're trying to turn ordinary metals into gold. They're whispering ancient incantations and mixing unknown substances. There's smoke, hissing, fluttering, and disappointment. Guys, you can try as much as you want, but you won't succeed. At least for a few thousand more years, until 2025. Scientists have achieved what alchemists were dreaming of for centuries. They didn't use magic or spells. Neither did they mix different substances. They used a giant tube about 17 miles long to accelerate lead molecules to speeds close to the speed of light. In a sense, the Philosopher's Stone appeared inside the Large Hadron Collider. Oh yes, in case you didn't know, the Philosopher's Stone is a mythical stone that ancient alchemists believed existed, a stone capable of turning any metal into gold. So, scientists were able to do this inside the LHC, but it's not that simple. Technically, yes, they managed to turn metal into gold, but in fact, the amount of this gold is negligible, and it quickly disappears. By the way, the LHC allows you to accelerate molecules of different substances to a speed close to the speed of light, and thus shows us how the universe was born, only on a small scale. Why do this? More on that later. For now, let's get back to that gold. Scientists believed that the precious metal could appear as a result of the collision of 2 lead particles, but experiments have shown that gold appeared even without full contact. There are 2 explanations. One is more scientific and the other is simpler. Let's start with the first one. So, there are 82 protons inside the lead nucleus, and each of them carries a charge. Because of this, the electromagnetic field of the lead core is quite strong. When 2 lead particles fly past each other at almost the speed of light, their electromagnetic fields are compressed into a thin pellet. This creates a short-term pulse of photons. The pulse triggers a process known as electromagnetic dissociation, when a photon interacts with the nucleus, causing internal vibrations. These vibrations emit neutrons and photons and change the essence of the element. When 2 lead atoms fly past each other, they lose 3 protons and turn into gold. This way, scientists managed to produce 89,000 gold cores per second. Unfortunately, this is too little, 29 picograms in total. This is much less than 1 gram. These gold particles are also short-lived. They are so energetic that they immediately crash into the walls of the collider. After that, they instantly decay into protons, neutrons, and other particles. Technically, there is gold, but there's too little of it, and it disappears instantly. And now, a simpler explanation. 2 lead atoms are flying at each other at almost the speed of light. They're surrounded by powerful electric field and have 82 protons each. When they fly close to each other, their electric fields become even stronger and push 3 particles out of each other. Now they have 79 protons each, which means that they have turned into gold. And these happy golden particles fly in different directions and crash into different parts of the collider. That's it, there's no more gold. Scientists used a special device to see this process. During the 3 years of the operation of the collider, scientists have been able to create 86 billion gold atoms. It's much less than a gram. Actually, it's less than a billionth of a gram. It's possible to get rich using such a transformation, given that the price of the Large Hadron Collider is several $billion. So why is it necessary? For science, obviously. Yes, it doesn't sound very useful, but the collider wasn't built to turn lead into gold. Its purpose is to explore our universe through the micro-universe. For example, the LHC helped discover the Higgs boson. You probably haven't heard anything about it, but it's one of the greatest discoveries of recent times. Let me explain. A barbell, a hair, an apple, a drop of water. All these objects have different weights. But why? What makes them have a certain mass? Scientists have suggested that the entire universe is filled with the Higgs field. It's like an invisible syrup. Some particles get stuck inside this field and become heavy, like protons. Others easily glide through this syrup, like particles of light, photons, that have no mass. Without the Higgs field, atoms would fly apart, and then nothing would have any weight. Imagine how chaotic the universe would be. So in 2012, scientists were able to detect a small piece of this syrup with the help of the LHC. They named it the Higgs boson. The Large Hadron Collider also helped to detect quarks. These are small particles that protons and neutrons consist of. They're like tiny pieces of Lego, forming a particle. Previously, scientists thought that each proton and neutron had 2 or 3 particles, but later they discovered particles with 4 and 5 quarks. It turns out that our universe is not built the way we thought. Okay, but why would we ordinary people care about that? What difference does it make if protons inside an apple are made up of 2 or 4 quarks? Wait, you'll get the answer soon. Inside the collider, scientists were also able to obtain quark-gluon plasma. It's the hottest substance in the universe, 100,000 times hotter than the sun. The plasma appeared when experts collided 2 lead atoms with each other. Scientists believe that at the time of the birth of the universe, such a red-hot drop appeared immediately after the Big Bang. That sounds pretty impressive, but what's the point? Be patient and wait a little longer. Some of the most impressive studies deal with the search for particle twins. Scientists suggest that the electron, for example, has a shadow twin, something like a superparticle, and the same applies to everything in the universe. Scientists have not yet found such twins, but who knows what will happen in the future. The presence of doppelgangers will help us find out what dark matter is. This unknown substance makes up about 85% of the universe, but we know almost nothing about it. Gravity keeps planets in orbit, prevents Earth from splitting into billions of pieces, and keeps us on our feet. But gravity is invisible. It's some kind of force that works because, no one knows why it works. Dark matter can help answer this question. Scientists believe that when 2 particles collide, dark matter particles are born, and they want to detect this moment. The LHC changes our understanding of how the standard laws of physics work. It has shown the existence of invisible, unknown processes within the universe. The LHC allows you to unravel the mystery of quantum physics. So far, we have more questions than answers, but work is constantly underway. And of course, a question arises. Why is all this necessary? The answer is, we don't know. Yet. Physicists receive billions of dollars to conduct strange experiments where they disperse tiny invisible particles and collide them with one another. It's like learning complex mathematical formulas you will never use in life. Can't we spend this money on something else? The fact is that all these expensive studies inside the collider help us understand this world better. They change our perception of how the laws of physics work in our universe. Let's look into the past. Scientists like Michael Faraday and Thomas Edison also did some strange, incomprehensible things related to an invisible thing called electricity. But thanks to that research, we now have phones, laptops, music, speakers, computers, hairdryers, water heaters, and everything else that modern life seems impossible without. And it all started with scientists conducting experiments with some invisible energy. Look where we are now. It's difficult to imagine where the research of quantum physics will lead us in 50 or 100 years. Perhaps we will be able to travel between parallel universes or learn how to teleport.